In this lesson, we will learn about paleoclimatology, which will include how paleoclimates are studied, climate change, and the applications of it in our society. But before we get into that, why study paleoclimates, and why is it important? Paleoclimatology is important to humans as a species. By understanding past climates, we can explain how current ecosystems are formed. For example, climate controls what types of plants grow in a certain area. Paleoclimatology also provides data that scientists can use to predict future climate changes. Computers can also use this data to show the potential effect of increased pollution in general, and of carbon dioxide on the Earth's climate. Since the Earth is so complex, it would be hard for scientists to predict future climate changes and how it would affect real life. However, paleoclimate data are used as a reference line for scientists by providing info such as rates of climate change and how plants and animals reacted and evolved because of that change. By using the collected data, people can predict and come up with ways to respond to future climate change. Paleoclimatology is the study of past climates. Since scientists cannot go back in time to see what climate was like, scientists use imprints that were created in that time period to interpret paleoclimate. These imprints are known as proxies. They are organisms such as diatoms, coral, and forams. Scientists can use records of proxies to reconstruct past climates to study. The proxy records can then be loaded into computer models and can be used to confirm past climates and to predict future climates. Forams, or the scientific name Foraminifera, and diatoms are commonly used climate proxies. These organisms are shelled and can be found in marine and aquatic environments. They can be planktonic or benthic, which means floating on top of water or located at the bottom. Diatom shells are made up of silicon dioxide, while foram shells are made up of calcium carbonate. They record evidence of past climate conditions in their shells. The remains of foram and diatom shells can be located by taking sediment cores from oceans and lakes. Because their shells are well preserved in the sediment when they die, the chemical composure of these shells show water chemistry at the time of the formation of the shell. Past water temperatures can be found out based on the stable oxygen isotope ratios inside the shell. These isotopes are found naturally in dissolved water and in the atmosphere. For example, if the water is warmer, the lighter isotopes tend to evaporate off. Therefore, shells grown in warmer weather will be enriched in heavier isotopes. Measurements of stable isotopes of planktonic and benthic foram and diatom shells have been recorded for many hundreds of deep sea cores all over the planet. Scientists can use foram and diatom population changes to determine past climates. Relative abundance and species composition in certain areas may be a sign of environmental conditions. Warmer weather will cause organisms to multiply. Also, since each species has a particular set of ideal growing conditions, species composition at a certain time and place may indicate past environmental conditions. Here are some examples of different kinds of proxies. Sediment cores. Sediment lamentations can show sediment rate through time. For example, charcoal trapped in sediments can indicate a past fire. Remains of organisms such as diatoms, forams, microbiota, and pollen within the sediment can point at changes in past climate, because each species has a limited range of survival conditions. These organisms and pollen sink to the bottom of oceans and lakes and become buried in the sediment. Ice core records, such as deep ice core records from Antarctica, can be analyzed for stable isotope ratios, trapped gas, and pollen trapped between the layers of ice to determine past climates. Tree rings can be counted to determine the age of a tree. In addition to this, the ring tells more than just age. The thickness of each ring can be used to determine fluctuations in precipitation and temperature, since the most favorable conditions for the species will result in more growth. Burn marks and scars can indicate a past natural disaster or an event, such as a fire. There are several major factors that affect climate change: changes in solar output, changes in atmospheric content of greenhouse gases, changes in distribution of continents, and changes of the orbit of the Earth. The Milankovitch theory states that variations in the Earth's orbit cause climate to change over time. Eccentricity, changes in the shape of the Earth's orbit around the Sun. Obliquity, variations in the axial tilt of the Earth. And precession, how the Earth wobbles on its axis affect climate. These can lead to fluctuations in the amount of solar radiation the Earth is getting from the Sun, and can result in major changes in the climate like ice ages over long periods of time. When discussing the topic of climate change, it is very important to consider the timescale. Long term, hundreds of millions of years. Medium term, 1 million years. Short term, around 160,000 years. And the modern period, hundreds of years. Timescale is important because it affects how climate changes are interpreted. In long timescales, major climate changes like ice ages are easily noticeable. Viewing long-term data can provide scientists with a big picture of climate trends. Short-term changes, for example, if this summer is colder than usual, can exist even though the long-term patterns indicate a warming trend. Because of this coexistence of short and long-term changes, it complicates scientists' analysis of climate change. Review. Studying paleoclimates helps us know how ecosystems are formed while providing data that scientists can use to predict future climate changes. The commonly used proxies are forams, diatoms, coral, tree rings, sediment cores, and ice cores. Planktonic means floating on top of water, while benthic means dwelling at the bottom. Past water temperatures can be found out based on stable isotope ratios inside the shell. If the water is warmer, the light isotopes tend to evaporate off. Therefore, shells grown in warmer water will be enriched in heavier isotopes. Relative abundance and species composition in certain areas may be a sign of environmental conditions in that area. For example, if the water was warm, organisms multiply. The Milankovitch theory states that variations in the Earth's orbit cause climate to change through time. Eccentricity, changes in the shape of the Earth's orbit around the Sun. Obliquity, variations in the axial tilt of the Earth. And precession, how Earth wobbles on its axis. When discussing climate change, it is important to know the timescale. Long term, hundreds of millions of years. Medium term, 1 million years. Short term, around 160,000 years. And modern period, hundreds of years. I hope you learned something today. To put your knowledge to the test, here's a question for you to think about. What if we never studied paleoclimates? And how might today's views on climate change and the environment be altered? Thanks for watching.